Right, over to you, Jasmina. Enjoy.
Okay, so as it has been announced, my name is Yasmina Stukhli, and my topic for today is about STEM, or now called STEAM in English language teaching. My idea for today's webinar is to shortly discuss 5 disciplines of STEAM and then to demonstrate some of the examples from my classroom, which I have done either as single STEAM lessons or multiple STEAM lessons, which actually were projects. Hopefully, we will have time for questions at the end of the session. But before we start, I would like you to answer, how often do you step out of your comfort zone in the classroom? So 1 is for often, 2 is for sometimes, and 3 is for never. Let's see some answers. So, oh my God, you are so fast. Javeria says 2 sometimes, Alana often, Ma Olivia often, Muhammad sometimes, Olga sometimes. Okay, Marta also sometimes. Thank you. Well, when it comes to STEAM, it definitely means leaving your comfort zone and venturing into some disciplines we aren't quite familiar with. How did I step out of my comfort zone? Well, it was a few years ago, and it was Halloween, and my students had a Halloween lesson with Miss Molecule. I was even wearing this green wig, lab coat, and some glasses. So using very, very simple items such as vinegar, baking soda, plastic bottles, Ziploc bags, etc., I was teaching my students about bases and acids. So, for example, in this activity, we were making witch potions by mixing food coloring, vinegar, and baking soda. I was also teaching my students about properties of polymers. So they would inflate the balloon, draw something they associate with Halloween, and then try to put the wooden skewer without through the balloon without actually popping it. Trust me, it is possible. We were also learning about a light refraction. So students would draw something they associate with Halloween on a piece of paper. They put it in a Ziploc bag. They zip the bag, and when you put the drawing, actually the bag, into the water, and when you stand above it, it seems as if it actually disappears because of the light refraction. Do I remember any of these from my primary or secondary school? Of course I don't, but I wanted my students to understand why certain things happen. So I first had to learn them myself. What is actually, oops, sorry, this was too fast. What is actually STEAM? It's an educational approach to learning and teaching that integrates 5 disciplines: science, technology, engineering, art, and math. You see, science isn't just about experimenting, although children really love it. And there are many simple things you can easily do with many simple items. Science is also about employing the scientific method. So hypothesize, observe, test, conclude. So for example, for all the activities I did in the Halloween lesson, I would ask my students, what do you think? Can I make a drawing disappear? And of course, my students would say no, but then I actually demonstrated that it is possible. When it comes to T, T stands for technology, and most children, my own too, use mostly computers or phones to play games. However, we want to teach our students to use technology for learning. Trust me and don't get discouraged, but do expect your students to quickly beat you in every app you demonstrate. So you teach them something, but they quickly get better at it than you actually are. And I always admit that to them. Also, T in technology doesn't only stand for power tools, it also stands for simple tools such as wheels, levers, scissors, etc. And these actually support children's cognitive development because when playing with them, children understand how certain tools help us accomplish different tasks. Engineering reminds me, for example, of constructing or building something, and students really enjoy these activities as well. However, engineering is also an important process of designing and creating something in order to solve a problem. And as you will see, problem solving is very important in STEAM, and I will talk about it in some projects that I have done with my students. A stands for art, and it can involve drawing, dancing, playing music, singing, writing, role playing, or acting. And I guess I think you will agree with me, we do all of these activities in our classrooms. Finally, there is math. Math isn't just science and study about numbers. It's also about different concepts such as size, proportion, comparison, forms, patterns, grouping, etc. According to different authors, STEAM means combining two or more STEAM disciplines in order to design a joint learning experience. So you don't have to have all 5 disciplines. However, if you can, it's much better. Let's see some of the STEAM lessons I have done. I did so many, but today I will talk about some recent ones and some of my students have really enjoyed. Our animal is the idea I learned about in a webinar. So I did this lesson with 9-year-old students. They use bricks to create an animal and write about its name, colors, where it lives, what it eats, what body parts it has got, etc. If you can't find bricks, you can use different kinds of waste material and have a recycled animal. As students are working in groups, you have to tell them how their work will be evaluated. So if they give an animal, their animal, if they give the name that has 3 words, they get 3 points. If they make one adaptation to the original animal, they only get 1 point. If they make more than one adaptation, they get more points. And here is what you get. So these were 9-year-old students. They designed beautiful animals. Their animals are named Mega Fire Phoenix, Big Robot Spider, Mini Finny Ini. Their animals live in the jungle or the volcano or on the buildings. They eat takis, fire fruit, grass, or insects. They got wings, fire tail, or 6 arms. They can fly, climb, shoot lasers, breathe fire. Some of them are dangerous, some of them are intelligent. So there is a lot of interesting ideas. So my question for you now is to write in the chat, what STEAM disciplines do you notice in this activity? So 1, if it's for science, 2 for technology, 3 for engineering, 4 for art, 5 for math. Please do write all of these that you actually notice. So somebody says all 5, somebody says 1 to 5, Gloria says 1, 2, 5, Marwan says art, Djokovic Dragana 3 and 4, Joyce says art and technology, Maida says 2 and 3, Zaina 1 and 4. You see, as we are dealing with animals, we still have some science because biology and zoology teaches us about science. Also, we have some engineering. They are designing and creating something. They are building something. We also have art as well. And I've seen many answers with 5, which is actually a correct answer because you cannot put 2 Lego bricks together without any knowledge of math. more ideas for STEAM lessons. And another question for you. What do you think? Has science got to do anything with grammar? If you answer yes, explain how. Rina, I apologize if I don't read some names as I should. Lami says yes. Surendra says no. Marina says yes. Simon Ewell says yes, it has rules. Ifedayo says it deals with language. Of course it does. Kader says yes, as science depends on rules. Okay, thank you, thank you. You see, I was teaching zero conditional by practicing science with my 10 to 11 year old students. As you can see, again, materials were very simple. From plastic cups, water, oil, sugar or candies, coins, metal marbles, magic sand, or it can be replaced by cocoa powder or cinnamon, some eyedroppers, measuring spoons, and phones to measure the time. So I explained zero conditional, I provided some examples, and then the students moved to this so-called scientific method. They hypothesize what usually happens when we do some things, they test their hypothesis, and then write a conclusion. So students were working in groups, and all the groups had their materials and a worksheet. So we wanted to see what happens when we put candy in cold water, what happens when we put coin in water, what happens if we put magic sand in water, or if we put finger into the magic sand. Again, you have to tell your students that it doesn't matter if their hypothesis will be right or wrong. What matters is the process of proving or disproving their hypothesis. So at the end of the lesson, the groups presented their findings, and I was explaining the science behind them. So my students were able to learn that water is universal solvent. It can dissolve many substances such as sugar or candy, even though some take longer to dissolve. They have also learned that water and different types of matter have density. If something is denser than the water, it floats. If something is denser, it sinks. If it's less dense, it floats. So, for example, metal marble would sink, oil would float. As these were very young students, they expected magic sand actually to dissolve in water. However, they have discovered that magic sand floats on the water, and when they put their finger into the magic sand, their finger stayed dry. So we learned that magic sand is hydrophobic. These were very young students, and I explained that hydrophobic means afraid of the water. Students also learned about cohesion. So drops of water on a coin do not spill due to cohesion. I think in our case, we had like 5 drops of water. So I told my students to imagine cohesion like friendship and to think of themselves as little water molecules holding hands together with their friends. It is actually this friendship or this bond that makes them stick together. Again, we had several disciplines involved. We were doing science. We used measuring spoons. We were measuring things. We used phones to measure the time needed for different materials to dissolve. I do a lot of STEAM lessons with my older students. However, projects seem more fitting with them. So 2 years ago, I designed, implemented a learning scenario with my 13-year-old students. So I used the popular song by The Clash, Should I Stay or Should I Go, to title the project Should I Breathe or Should I No? You see, I live in the city of Tuzla, which is very famous for 3 salt lakes in the very center. So in summer, this is packed with people. The town is full of tourists and it's very lively, and do come visit us. However, do not come in winter. This is a photo of the city taken from the hill in winter, and this is not fog, this is actually air pollution. This region is known for a long history of coal mining, a large coal power plant, and most people use coal as the source of heating. So air pollution is a very serious local problem. What I wanted for my students was to identify causes and effects of air pollution, to evaluate gathered information and data, and most importantly, to develop strategies to protect themselves. At the very beginning, my students knew just few causes of air pollution, such as cars, houses, power plants, and just few effects such as coughing, heavy breathing, or sore eyes. I then played a very short video called Air Pollution for Kids. It's like a 10-minute video, but very, very informative. I also used the opportunity to teach my students how to use Canva. Canva is online graphic design tool with a lot of free material. So let's say in some 10 minutes, I demonstrated how to add text, shapes, how to add images, how to add animations. And very soon my students beat me in using Canva, which is actually what I expected. But this is the tool they hadn't used before, but continued to use during the project and later on in other subjects when making presentations, which is what I'm mostly proud of. So during this lesson, they listed what they knew from our discussion and what they learned from the video, and we created one poster on air pollution. So at this very point, students could say that the causes can be natural or man-made, that the effects can be different from acid rains, breathing problems, to allergies, lung and heart disease, etc. Wanting my students to use technology for learning, we brainstormed some of the topics to be researched. So they had to do a research about PM 2.5 particles, which are actually particles found in smoke and which are measured in winter and show the quality of air. They also had to do a research on number of children affected by air pollution, as well as diseases caused by air pollution. They formed groups of 2 to 3 students and had 2 weeks to do a research, prepare posters and presentations for their classmates. What they have actually taught us is that these 2.5 PM 2.5 particles, they have 2.5 micrometers in diameter, are found in smoke, that they get into the lungs and the bloodstream. We learned that children are at much greater risk because they play closer to the ground where the concentration of polluting materials is higher, and children breathe through the mouth rather than their nose, which results in increased amount of inhaled pollutants. We also learned that 1.8 children breathe polluted air, which can cause cardiovascular diseases, pulmonary diseases, cancer, sore eyes, throat, and also have effects on cognitive development. Then the time for the science came. So we already had our question, should we breathe or should we know? Students have done research, and now was the time to set a hypothesis and do an experiment to make a conclusion. So in this very, very simple experiment, students constructed air pollution catchers by applying some Vaseline on paper plates. They would make a hole in the plates and then hang those air pollution catchers around various places. Some students suggested using contrasting locations to see if we would have different findings. Also, everybody has given their hypothesis. So they said, I believe the air pollution catcher will remain clean, will get clean. So their hypothesis differed according to the place of their catcher. One student decided to put his air pollution catcher in the forest. This student even designed a cover for his catcher. All the catchers had to be observed for periods of 2 weeks. And as everybody expected, this air pollution catcher remained clean. So the forest was our healthy test environment. Another student suggested placing the catcher in school coal boiler room because this school also uses coal as the source of heating. So the changes on this air pollution catcher were quite striking. Although these PM 2.5 particles cannot be seen by the naked eye, the changes were quite visible. I mean, everybody in my hometown knows that there is no white snow around the coal power plant because of these particles that the power plant emits. The snow is always black or grayish. To add more science to the project, I also introduced the notion of temperature, practical demonstration of temperature inversion. Temperature inversion is a very natural phenomena in our city. So in normal conditions, warm air is closer to the Earth's surface, and with the increase in height, the air gets colder. However, under some natural conditions, cold air stays down, warm air goes up, and it creates this inversion layer which doesn't let the smog, the air pollution disperse. How did we do this practically? With very simple items such as jars, tube, funnel, water, food coloring, and kettle to boil some water. So to demonstrate normal conditions, we poured cold water, which was colored blue, in a jar. We used a tube and slowly through the added hot water, which was colored red, through the funnel. In this case, actually, the two colors have mixed. To demonstrate temperature inversion, so you first pour hot water into the jar and then slowly add blue cold water. So you will see that the cold water pushes the hot water up and it creates this invisible layer between the two colors, which is like this trap that doesn't let the air pollution disperse. This also helps students to understand that it is not always the human factor contributing to the air pollution, but it can also be natural. And it helped us practice some vocabulary such as, I don't know, jar, tube, kettle, or some cooking verbs such as boil, pour, sear, etc., etc. To add some engineering to the project, I collaborated with my colleague Sanela. You see, in her lessons, students made models of solar-powered house, windmill, hydroelectric plant. The idea was for the students to learn about green power production. And I have to admit, they were very successful in generating electricity. In my learning scenario, they had to present their models in our mother tongue. So you can only imagine how surprised I was when my students started talking about solar panels, inverters, storage, wind turbine, generator, reservoir. I was really very, very happy. Also, my friend and colleague Mercida, she helped us calculate the number of trees needed to absorb CO2, which is produced by this coal burning power plant. So students first had to find out that this plant produces 2.5 million tons of CO2 in 1 year, and one tree can absorb just 21 kilo. So using the formula, they calculated that we need almost 120 million trees. Then they had to find out, then they found out that one tree takes about 9 square meters, and having all these trees in mind, they calculated it would take the area of 1,000 square kilometers. We have some territorial divisions in our country, so the Tuzla has also this Tuzla Canton with the size of 2,600 square kilometers. So we came to a number that 39% of this canton should be covered in trees just to absorb CO2 produced by the power plant, because we don't have data for other causes of air pollution. Again, I was very surprised by the way my students were able to explain these complex math calculations in English language. Having all these data and information at hand, they suggested some things to do in winter. So to protect yourself, you should monitor air quality apps, stay indoors, reduce outside physical activities, wear appropriate masks, or go hiking in the mountains. So I think I have, with all these activities, provided a well-rounded experience with all 5 disciplines being intertwined. However, students writing and speaking using STEAM-related vocabulary was definitely my biggest reward. I think we have time for one more project. So let's see, write in the chat, how do you teach irregular verbs? Okay, Kader says bingo game. Aregi says with song. Martinez also with bingo. With song, let's practice. Anna Maria says through stories. Shimets, it goes too fast. With song or card games. Joyce says with movement, excellent. Diana Gomez with flashcards, Irene with examples, in context by Erika. Those are all great ideas. You see, last year, I again implemented another project. Can singing help you learn a language? So the aim of this project was to teach the group of 5 talented students the scientific method, hypothesize, test, observe, using the STEAM approach and project-based learning method. So we started by giving the hypothesis, can singing help you learn a language? So I had a group of 5 students, most of them said yes, but there was one student who said that it cannot help us because it's for fun only, not for education. So 4 students said yes, 1 said no. Again, I had to remind them that the process of proving or disproving the hypothesis is what matters, not if it was wrong or not. So to design and test their hypothesis, they had to create a list of up to 30 irregular verbs that rhyme in past simple. We were doing only past simple. They had to prepare a worksheet with 5 different types of tasks, create a Kahoot quiz with irregular verbs, and do a research on language learning by singing. So in just 45 minutes, which is how long our lessons take, they made irregular verbs rhyme with 24 verbs. They created a worksheet with 35 examples. So here are the tasks were like match, put the verbs in past simple, choose the correct verb, choose from the list. They also created Kahoot quiz with 15 questions with those 24 irregular verbs that they have put into their irregular verbs rhyme. So what we wanted to do is to test effectiveness of 3 different methods or activities in classes 7A, 7B, and 7C. All classes were practicing irregular verbs. The introduction and final part of the lesson were same in all 3 classes. So in the introduction part, we revised past simple. In the final part, students played the Kahoot quiz. What was different, during this introduction and final part, the group of these 5 talented students were testing their peers. So we wanted to see how many irregular verbs students knew before the lesson and will know after the lesson. And it was the main part of the lesson that actually differed. So in class 7A, we had singing. In class 2, we had a controlled practice. In class C, we had combination of 1 and 2. So how did it actually go? This sounds much better with music, but since I have no music now, I will try to show you. So you use a hip-hop instrumental, and it goes something like this. When I say take, you say took. Take, took, take, took. When I say shake, you say shook. Shake, shook, shake, shook. It is actually this yellow part that students have to say. So they just say past simple irregular verb form. I have to tell you that the atmosphere in the classroom was very energetic. I just demonstrated the activity once, and then students took on my role. In class B, students had controlled practice. They were doing this worksheet prepared by this group of these 25 students, and the list of these irregular verbs was displayed on the board in alphabetical order. Finally, in class C, we had some combination of these 2 activities. Which activity do you think was the most successful? 1, singing, 2, controlled practice, or 3, combined? So Olivia says singing. Aisha also says singing. Allegra Ristovska says combined. Maha Otman singing. Filipe singing. Simon Newell says also combined. Anna Maria says singing. So I think that we all have at least a little bit of similar opinion. I actually expected combined methods to be the most successful. However, the group of these students analyzed the data and prepared presentations as well. What their research has shown is that in one class with the singing method, we had 50 verbs learned, with combined method 41, or with controlled practice 30. If you take those results per student, so 10 verbs per student with singing, 8.2 with combined method. Although this is very small research, because these 5 students tested, like 5 students in each class, so we had 15 students tested in total. They have given us a ground to do additional research. So working in the classroom, and again using both Padlet and Canva. Padlet is like online collaboration tool. I wanted my students to share the information so that in the final presentation we don't get the same resources or the same information. They used Canva to design these beautiful posters which were displayed in the school hall together with the results of their experiment. And they have also given presentations in all 3, 7A, B, and C classes where the experiment was performed. We had a lot of material, so we even designed a project newspaper in our mother tongue. I used their video to present the project activities to the Council of Teachers. So their research has shown that singing helps us with learning new vocabulary, practicing speaking and listening skills, grammar. We learn about culture, we build self-confidence, and it's a fun way to learn. What is important when it comes to STEAM is that it doesn't only help us develop students' English language skills. It also helps us to help them develop, it provides ground for them to develop 21st century skills. When it comes, the first one is communication. So they present their ideas, they share, they discuss, they write, they talk, etc. So they practice their public speaking skills as well. Also, they have to collaborate to reach the common goal. So they combine their strengths in different areas to be better. Also, STEAM provides possibilities for students to express their creativity. So you have seen those beautiful animals, but not just their creativity in building, in graphic design, in writing, rewriting either irregular verbs rhyme or this rewriting of the song. Also, STEAM helps students develop critical thinking skills. So they analyze data, they try to find some solution by integrating knowledge from all these four disciplines. My question for you is, which of these activities do you think you could use in your classroom? So one, the animal, which can be made even with the waste materials, zero conditional, air pollution project maybe, or learning by singing. If you think you can do all 5 of them, please write 5. So Cornelia says 5, Shimets 5, Asma says all, thank you. Ibrahim says also all. Thank you. Maria says 1 to 5, so it's all. Lami says 5, all. Thank you. Thank you. 1, 2, and 4 says Gabriel. Thank you. My dear Maida says the animal and learning by singing project. So what I would also like you to do is write some of your reflections on all these activities, my presentation, in the chat or in the comments. I know that many people are great. I see somebody says my voice is terrible. My voice is terrible too, but you can use AI to generate the rap song, or you can just have your students just demonstrate to them by speaking and then have your students singing. I really hope that these activities will try to a little bit inspire you to start practicing STEAM, I suggest start with maybe 2 disciplines and then slowly add one by one. Sandra says, wonderful session. Thanks, Yasmina. Thank you for listening. You went above and beyond with the research. Thank you. Thank you, Maida. I hope we will be able to see these chat comments later. Will we?
We will, yes. Yes. I can save the chat and share it with you after the session.
Yes, because I would really like
Good comments.
to read it. Yes.
Yeah.
So
Thank you
you
so
can
much.
find me on most social media. Do we have time for questions? Yes, we do.
We do, yeah. Perfect. Wonderful. Okay, so we'll share all the links and references in the chat. You can stop sharing your slides now, and then people
Okay.
can see us a bit better. Great, thank you. That was so interesting, and there's loads of questions and loads of nice comments. I just wanted to share a nice comment that we saw earlier in the chat from Corinne, who says there was a point where you were talking about having colleagues collaboration.
Yes.
This means you have colleagues collaboration. That is really marvelous. How
Yes.
important is that when you're teaching different subjects through English?
Well, I am very bad with electricity. So if there is something going to burn in my house or burst, I will be the one turning on the light. So I really wasn't, I was actually afraid to venture into this area of designing windmill or I don't know, hydroelectric plant. But what is good is that we have this subject, it's called technical culture, where students learn actually to use everyday tools and power tools to build and design something. So I talk to my colleagues whether you would do it, and when you collaborate with colleagues, you also demonstrate collaboration to your students.
Yeah.
I could easily calculate the number of trees with my students, but I wanted my students to see that even we as teachers from different disciplines collaborate with different things.
I love that. That's so nice to make that link with other subjects, bring those
Yes.
into your classroom and like you say, to demonstrate teamwork. That's great.
Thank you.
Okay. Do you find you have to translate a bit sometimes to help with key concepts?
Yes, with this project with air pollution, so the vocabulary was very difficult. This project with the air pollution, I have even published a paper about it. I think it's titled "Should I Breathe or Should I Know?" and you can easily find it on the internet. What I had in the classroom were those faster progressing students who actually acted as simultaneous translators. So students were sitting in groups discussing, and from time to time I would switch to our mother tongue just to check if they had understood everything. We even had conversation with my friend who works at the clinic. She's a doctor oncologist. Because I know that she speaks excellent English, I invited her because one thing is when you read about something, and one thing is when you have another thing is when you have a doctor who like actually confirms your findings. The way she made her language easy and simple for students to understand was really, really amazing.
That's great. It's so nice to hear about exactly how you're doing it. And this
You
relates
just have to be creative, find different ways.
Yeah. So there's a question, an interesting question from someone in Zoom saying, isn't there more science and less English when we do STEAM merged with English? How do you see that balance between the two?
Well, I wouldn't say it's more science, especially for example, in this project with singing. Maybe the other project with the air pollution, well, the focus was a little bit on the science. However, we still combine other disciplines, and still all the disciplines involved English language. You see, when the students made those models, when I was preparing their learning scenario, I didn't actually plan for them to present the models in English. So they decided to present in English. So they had to find out how to name different parts of solar house, or I was really stunned.
Wow, that's amazing. So when they're motivated, they go off and
Yes,
and they
yes.
do it
And
for
what
themselves.
good thing is that in this air pollution project, for example, I didn't form groups. I let students form groups. And I remember three girls. One said, I will do the design. The other said, I will find the information from our local health institution. The third said, I would translate. So they combine their strengths.
That's so good. And do you have any strategies for helping students with teamwork? Because that's obviously excellent teamwork. How do you
Yes.
demonstrate
Well,
that to the
we
students?
often, I do a lot of STEAM challenges. You can find many of those on the internet. For example, there is egg drop challenge. So that you give them everyday items. They have to drop the egg from a certain height and the egg mustn't break. So they have to work. I do such things to build those team working skills. Or for example, I get them to like design a tower, to make a tower of plastic cups, but I tell them that they mustn't talk, so they have to be silent, and the group who designs the tallest tower will win. So, and we constantly reflect on how they were working as a team, what they did, and etc., etc., etc. So there are again STEAM activities which help students practice their team building skills.
Excellent. I like that. I also liked just thinking about how you motivate students to do well. I really liked your point system where if you for an adaptation,
Yes.
the building with the bricks for an adaptation.
Well, in the bricks animal, I expected boys to be more engaged. So I expected, because mostly boys play with bricks and design different cars and I don't know, vehicles, etc. I expected them actually to overtake the group work. And I was really surprised how the girls actually participated by, I don't know, explaining them, let's put this part here. So at one point I saw like a group of students where each child was building a separate part, and then they put it into one. Actually, they did put it into one
Wow.
animal. Yes.
Wow. Another great strategy. There's different
Yes.
ways to do the
Yes.
same thing, right?
Well,
Um,
I think that children often surprise us with their
yeah.
ideas, with their creativity, and the way of thinking outside the box.
Definitely. So there's lots of questions about like how exactly you do this, the time you dedicate. There's one from Sophia. She says, "Hello, Yasmina. Please specify how much time of a STEM class you allocate to teaching language."
Well, I do everything in English. So all the activities are in English. And I guess we can all see in our students' faces when they don't understand something. I have to admit, I often switch to their mother tongue just to check their understanding. You see, the properties of water, the cohesion, universal solvent, etc. Those are very, for me, concepts that I didn't actually know and also had to learn them myself. But I try to find the simple ways to explain something to them. I don't ask students to be able to explain the concepts I taught them. I just
Right.
wanted to understand them.
Okay, that's interesting. The focus is on understanding.
Yes,
And
because CLIL would be more if we wanted students to be able to explain the processes or some concepts or notions from science in English. I think that would be rather CLIL than STEM.
right, but you must. Do you have strategies for pre-teaching important vocabulary, for example?
Definitely. So, for example, when students were giving presentations about the different diseases caused by air pollution, I talked about what's pulmonary, what's cardiovascular, what's heart, etc., etc. But then in our language, you also say cardiovascular. So, yes.
Okay, so
some words are very similar. Yes.
They're learning at the same time. Okay. Right.
Oh my God, there are so many comments in the chat.
So many, I know. This hopefully a quick question from Maha, who says, what about the ages of the students? I think you said that, but could you recap?
Yes. So the animal was with the 9-year-old students, but I even think the older students would also enjoy the activity. Water property, I did it with students who were 10 to 11 years old. Singing project with 12-year-old students. Air pollution with 13-year-old students. So I somehow balance the activities. But I sincerely suggest to read about some like simple, easy, no prep STEAM challenges, because you can do them with a piece of paper.
Right. Yeah. And how do you choose the topics? Do you look at what they have to study in those other subjects to link, or do you just choose things that seem interesting?
Well, I want them to, sometimes I look at what they learn. For example, when we were creating this animal, students just have finished learning about animals and body parts and verb have got. So I wanted them to revise that. When it comes to air pollution, I wanted them to deal with the real world problem. Also with this singing project, we were just about to study irregular verbs, so I chose the topic to do it a little bit differently.
Yeah, okay. Right. So I see you're linking the projects to the English syllabus more than to.
Well, sometimes yes, sometimes no. So for example, the air pollution is not in their curriculum.
Right, okay.
But I am allowed to make small changes to the curriculum, like some 30%. So I often do it.
Well, it's nice when there's a little bit of freedom to
Yes.
Yeah, sometimes we have the syllabus is so strict and so full that we have very little choice as teachers. Okay, let's try to answer another question. There's a question from Ma Olivia here. Hi, Yasmina. How do you balance creativity and safety when doing STEAM activities and still achieving the English learning objectives? Do you have any safety tips?
Well, in what way safety? Like not using AI or safety operating with certain tools? I don't really understand.
I imagine it's if you're using scientific equipment in the classroom, if you've got lots of students doing things.
Well, I usually make groups and each group does certain things, and I always use some unharmful things such as, I don't know, water, magic sand, baking soda, vinegar. And it's really good because when you have those items at hand, for example, I would tell students, take vinegar, and they say, what's that? And I tell them, smell it. And when they smell it, they actually learn what it is.
That's amazing. Right.
Yes.
Yeah, what is
so
that?
like with everything you do, you have a lot of realia at your in your hands. So you just demonstrate, they smell it, they don't taste it.
Yeah, right. Okay. So those ground rules are important, right? Don't smell things.
Yes.
Okay. Depending on what you're doing. Okay. Let's see if we can take one more question. There's people saying it was a great session.
Thank you.
What else have we got here? I think we've talked about I think that's clear actually. How many lessons did you produce for the pollution project? That's a question from Corinne.
Well, I really don't remember, but what I remember is that I gave the initial lesson. I introduced the notion of this temperature inversion. Everything else was actually performed by the students. So they did research, they made presentations, etc., etc. Yeah, so the math, creative writing, temperature inversion. So let's say some 4 or 5 lessons, but the focus was more on students doing research and then presenting to their classmates.
Yeah, I love that about projects. Well, it's a lot of work to prepare and to think through.
Yes.
But once students are working on it, it frees you as the teacher to go and work with individual
Well,
groups.
there was a lot of reading through their presentation and finding, like going through all the resources they have used. But still, even I have learned some things I actually didn't know about the air pollution. For example, this fact that children inhale a greater amount of pollutants. I really had no idea about that.
That either. That's
Yes,
really
or the number of people affected by air pollution.
Yeah.
I thought we were the only one.
Right, right. That's fascinating. Well, we're out of time, but thank you so much, Yasmina. It's been a real pleasure.
You're welcome. The pleasure is all mine.
How interesting and useful it was. So thank you so much. Thanks to Marcus moderating on Facebook and Melissa, who is here in the chat. We're going to take a short 15-minute break, and then we're going to be back for our next session, which is how can teachers use short stories? So if you're interested in using stories, then stick around. Thank you. We'll see you shortly.
Bye-bye.